Hi, today I will show you how you can create a project in HLS for door lock system. In this project, we will implement with Finite State Machine. There are 5 states of this machine where initially it will be at S0 case. The door lock code is 2346. So initially the state machine will be at this state. Here when user press other than 2, it will be written at this state. When user press 2, it jumps to the next state, which is S2 state. Here the door will still close if user enter other than 3, it will go back to 0, S0 state. If user enter 3, then it will jump to the next state, which is S23 state. If user enter wrong input, which is other than 4, then it will go back to 0 state, and then again you have to pass these 2 states. In other case, if user enter the correct key, which is 4, then it will jump to the next state, which is S2, 3, 4 state. And then if next key is correctly pressed, which is 6, then it will go to the next state, which is the open state, where the lock will open. So let's see how we can write C++ code in HLS for this state machine. Here I have written the C++ code in HLS where this is for AP-int header file included in our system as we are using the AP and int over here. This is our state machine declaration in HLS where type def enum and then the number of states we defined in our project and then state type. Then this is our input, which is 4-bit, and output is declared as a pointer. Here, after that, we will define its interface modes, which is none for this case. After that, this is our state variable, where static state type. The state variable is initially assigned as 0. The state type is another variable we declared here. Then the local variable for our main output, which is open local, initially assigned 0. 0 means close. Then enter our actual state machine code till here. Initially state is as 0, okay, as 0, and if x input is 2, then it will jump to the S2 case, otherwise it will remain in S0 case, and door local variable will be 0. Okay, and so on up to this case. If user reads successfully till this case, then the next state will be a 0 and the local variable will be 1 between door is open, and then in this switch case, and at the end we will assign the local variable to the main outputs, like this is our state variable which is declared here, and we assign the next state to our state value, and then the door open, which is our main variable for the output. Here we assign our local variable to our main output. After that, we will synthesize this design, and after synthesis successful, we will export this as an IP to our Vivado. Now the synthesis finished successfully. Then after we will export the RTL Vivado IP. It successfully finished the export process, and I have already created a project in Vivado where I will again assign this IP, where you can see this IP is created here, and then we will just add the repository, and you can see here the IP added in our repository. Here the clock and reset signal what is already added, and then this is our input and this is our output. So we can just use these input and outputs. These two outputs the default created by the Vitis tool. So we can ignore these two outputs. Here after design this, I created a wrapper where you can create a wrapper again and create a wrapper for this design and then used in your system. Here you can see the wrapper it is called in the system. Here then after you can simulate your system. After that I will force clock. So I will do the force clock. Input I will initially enter 2. Okay, then as you can see here, please keep subscribe my channel. Thank you very much.